Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so say hi to our friends over at Linode. With 200 gigabit private networking, scalable shared block storage, node balancers, and a 40 gigabit public network, all controlled by a brand new API, you get everything you need to scale up. Go to pythonpodcast.com/linode, Linode, to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. And if you're like me, then you need a simple and easy-to-use tool to keep track of all of your projects. Some project management platforms are too flexible, leading to confusion of workflows and days' worth of setup, and others are so minimal that they aren't worth the cost of admission. After using Clubhouse for a few days, I was impressed by the intuitive flow, going from adding the various projects that I work on to defining the high-level epics that I need to stay on top of and creating the various tasks that need to happen only took a few minutes. I was also pleased by the presence of subtasks, seamless navigation, and the ability to create issue and bug templates to ensure that you never miss capturing essential details. Listeners of this show will get a full 2 months for free on any plan when you sign up at pythonpodcast.com/clubhouse. So help support the show and help yourself get organized today. And don't forget to visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And don't forget to keep the conversation going at pythonpodcast.com/chat. Your host as usual is Tobias Macy, and today I'm happy to welcome back Anthony Shaw to talk about his project Wily, which is a command line application for tracking and reporting on complexity of Python tests and applications. So Anthony, could you introduce yourself for anyone who hasn't listened back to your previous episode?
Yeah, hi Tobias. It's really great to be back on the show. It's been almost 2.5 years now, 3 years nearly. I'm sure a lot's changed since then. So no, it's great to be back on. So I'm Anthony Shaw. By day, I work for a company called Dimension Data, looking at technology skills for the organization. And by night, I dabble with Python, make pet projects, and also blog quite a lot on different forums. And I make courses, Python courses on places like Pluralsight, and I also write for realpython.com as well.
And do you remember how you first got introduced to Python?
Yeah, it was quite a few years ago now. And basically, I was in a hotel in Seattle, and I was traveling for work and basically got really, really ill. And I was supposed to fly to New York City the day after, and basically had to stay in Seattle, which isn't the worst thing. It's a lovely place, and had nothing to do over the weekend because I had to stay in bed and rest. So basically, just got out my laptop and watched a whole bunch of Pluralsight courses teaching me Python. So that's basically how I got into the language. I think it was about 4 years ago now, so really not very long ago. Python's not the first language that I've learned. I can code in quite a number of other languages. C# probably the most experience in that.
And so you mentioned that recently you've been spending some time working on different pet projects, because I know that the last time you spoke, you've moved more into a management position and helping to train the technical organization at Dimension Data. So can you discuss a bit about what the Wily project is and what your overall motivation was to start working on it?
Yeah, so the Wily project is a tool that helps you understand the complexity of your Python code in an application. And it does that by looking at complexity from a number of different angles using different metrics, which we can have a chat about. And I think the most important thing is, because there's a number of tools to calculate code complexity, but they only really make sense with context. And if it just spits out a number saying your cyclomatic complexity is 502, for example, it's just like, okay, what does that mean? Is that good? Is that bad? And really kind of when I looked around at the tools that were available, that's really the frame of mind that it was in. So basically what Wiley does is it gives you a way of archiving that data. So it integrates with Git. So it can go through your Git history and basically run all the complexity metrics against your code. And it will give you a breakdown per module, per function, or even per class to show how complexity has changed over time.
And before we get too much farther in the conversation, I want to dig a bit into what software complexity is and some of the different ways that it can be measured and why developers should care about it at all.
Mm-hmm. Yeah, great. So I guess software complexity has been researched for a long time. Some of the metrics that we actually use in Wiley And some of the ones that are used in the broader community were actually, the first papers were done in the 1970s. So this is before Python, I guess around the advent of languages like C, but also a lot of people coding in assembler, for example. So basically the research was done to figure out how much cost there is in maintaining code of a certain size or length or complexity. So a whole bunch of computer scientists, some of those, for example, such as McCabe, Halstead, or another one, basically write a series of papers looking at complexity and trying to estimate how complexity could be calculated by looking at the code. So in terms of the metrics, I guess the crudest is lines of code. I don't know if you're familiar with that, Tobias.
Yeah, lines of code can definitely contribute to the overall maintenance burden of a piece of software because of just trying to keep everything in your head, and that's usually where you would start to break something apart into modules so that you can compartmentalize some of the logic functions. But it's definitely not necessarily a determining factor as to how complex or how difficult to understand the code is in and of itself.
Yeah, definitely. So I guess it's the kind of the crudest one. Lines of code is actually used as one of the base metrics in a lot of the other calculations. But obviously, trying to reduce lines of code doesn't always give you the right behaviors and encourage the right style in Python. I mean, for example, you're not really supposed to compound statements together in Python, even though you can. Spreading things out under, I guess the recommended line length is really to do with making sure that the code is nicely spread out and readable. So lines of code was kind of useful just to say, okay, is this project 1,000 lines or is it 10,000 or 1,000,000 lines of code? At least that gives you some sort of vague idea about how big it is, but not necessarily how complicated.
And I know that one of the tools is named after McCabe that is popular in the Python community, and that's for measuring something called cyclomatic complexity. And in my experience with it, it's generally based on the level of nesting with the logical flow of the program. So if you have an if block and then a for loop and then a while loop and then another if block, then that's going to be more complex than if you flatten that out and either break it into separate function calls or just figure out a way to make the code more procedural and reduce the number of nested iterations to it.
Yeah, so the McCabe metrics. So the McCabe tool is really useful as a library. There's another project called Radon, which basically provides a lot of these base metrics. It does lines of code, cyclomatic complexity, and another one called the maintainability index, which we can talk about in a second, which is a bit more complicated. But yeah, cyclomatic complexity is really looking at the number of potential branches there are in a code base. So for example, if you start at 1, if you add an if block or an if statement, then that pluses 1 to the number. If you add a while loop or a for loop, that pluses 1. For example, because Python, you can actually do for something and then else. So even if you don't have a separate branch, it does add 1 to the complexity. So the idea is that flat is better than nested, which hopefully some of the listeners have heard that phrase before. But encouraging, I guess, flat code is better for simplicity and maintainability, but it also makes it a lot easier to read.
And so in Wiley, what are the main factors that you're using for being able to compute a complexity score?
So in Wiley, what you'll get is you basically run the tool. It's a command line app. You give it the target folder where your source code is, and then I guess, which metrics you want to collect. So by default, it will look at raw metrics like lines of code, source lines of code, how many lines of comments you have, and how many modules you have, things like that, just some basic metrics. And then it will also look at cyclomatic complexity and basically calculate the cyclomatic complexity of each module, submodule, function, or class across your code base. And then another one is the Halstead metrics. So the Halstead metrics basically build on some of the concepts that are in cyclomatic complexity, but they look at more to do with sort of like the volume of the code. So lines of code, I guess, is the most crude measure, but there are some measures that you have in Halstead. For example, one of those is the number of operators that you've used in your code. Things like if, for example, or a less than sign is an operator. And then also that's an operand. And then it will look at the number of variables and other things you've used in the code. So you can calculate things like what's called the vocabulary metric, which is really to do with the number of names or variables you've used across the code. If that number is higher than it needs to be, it means you've used tons of temporary variables, and that can obviously consume a lot more memory, and there's a whole bunch of other side effects. And another one is to do with volume, which looks at the number of operators and operands in the code base, and then uses that as a way to calculate basically the size of the code. If you look at it in terms of, it's almost like calculating the size of the AST.
And with all of these tools in Python, it's definitely useful for being able to quickly get some feedback in your development process of how complex the code is. And because of the interactive nature of Python development, you can even get this information as you're writing the code, particularly if you have these tools integrated with whatever editing environment you're using. But I'm also curious what experience you have in terms of using these complexity measurements in other language environments and some of the other tooling that's available, particularly for projects that might span multiple languages.
Yeah, so my main experience has been in C#.NET. So it's a very different language to Python, more similar to Java if anyone hasn't worked with it before. And cyclomatic complexity is really important in C#, as are some of the other metrics. And where I've used it before is working on really large code bases and basically trying to identify, I guess, some of the hotspots in the code base, like where are the really complicated bits sitting, and how is that trending over time? Because it becomes useful if you want to sit down and do a refactoring exercise to say, okay, this part of the code, this module is becoming way too complicated. We've basically created ourselves an anti-pattern such as like a God class, for example, and you can see that through the complexity measures. So that's an indicator that you might want to go and refactor some of the code. So really, that's what those two types of tools are used for.
And as you mentioned, having the historical perspective of how the complexity of your application evolves over time is a valuable way to determine what are some of the potential risk factors within this code base. And I know that you mentioned that Wiley has the capacity to traverse the Git history of the repository for being able to compute that historical metric. So I'm wondering if you can talk about some of the ways that that can signal useful areas of focus and identify potential problem areas within your code base.
Yeah, so basically what happens when you run Wiley for the first time is it will, first of all, it checks that you've committed all your files in Git, otherwise you could lose them. So it basically runs off what I'm assuming is probably the head in your Git repository, or if you've checked out a particular branch, then it can iterate through the branch, and it will basically go and look at the history of commits, go and check out each one in sequence, working from the newest backwards, and then go and run all the metrics across the code base, and then it stores them in a small data folder. So you've basically got a cache locally that has got all the metrics across the code archived against the different commits, but also against the commit, it will record when that commit was, who made it, and what the message was when they committed it. So what the Git message was. So it's basically useful because Wiley gives you a number of commands to go and graph any of those metrics. So you could pick a particular folder, for example, or a particular module and say, show me how lines of code compares against a cyclomatic complexity for this particular module. And it will go and show you that as a graph with a line representing those two metrics. And it will, each data point will basically be a Git commit, and the bottom axis will be, so the x-axis will actually be the date that commit was done. So you can kind of look at it as a historical perspective, and you can hover over each data point and it will show you the Git message and the author. So you can see if there was a sudden spike in complexity, then why that was. So that's kind of, I guess, historical perspective. The other way of using it is to install it as a pre-commit hook. So if anyone hasn't seen pre-commit hooks before, they're a Python project which you can install into a particular Git repository, and Wiley can be used as a pre-commit hook. So if you make some changes to your code and you run git commit, it will actually run Wiley before it completes the commit process. And on the screen, it will show you basically a diff in any of the metrics. So if anything has changed across the code base in terms of the size, the complexity, it will give you a breakdown. So for example, if you made a change, added a new feature, and you did that in a particular class or function, then when you run git commit, it's going to pop up with a message saying, okay, the complexity of this module has changed by 5, the size of that module has reduced by this number, or this function has changed by this metric. So it'll basically give you a warning about how your changes are impacting the complexity, I guess, and the maintainability of the project.
And is that a blocking pre-commit hook, or do you just use that as an informative measure so that you know before you push it to the source repository whether you want to take another pass at it?
Yeah, it's not a blocking one. I have thought about introducing basically a configuration where you can say don't block it if it increases the complexity by a certain amount, but I could just think of so many edge cases where that's just going to annoy people. So I left that feature out.
Yeah, it's definitely a very subjective measure, and particularly if you're willingly making the trade off of increasing the level of complexity in order to be able to implement a feature because it is inherently complex, or just because it's the easiest way to get it working right now, and you have the intent of going back afterwards to then refactor it maybe once other features are incorporated. And so you were saying that when you're traversing the history and generating this historical perspective of the complexity over time, it's creating these data files in a subfolder to the project. And one thing that I was curious about there is how you implement any sort of collaborative view of that historical complexity, if that's something that you would commit as an artifact with the repository, or a way of integrating it into the overall continuous integration lifecycle of the project, just ways of sharing that view of the code and making sure that it's a team effort to maintain the complexity and keep it down and maintain the overall health of the project.
Yeah, so this is a bit of a tricky one. So at the moment, the way that you can do it by default, if you don't specify, it will put all the data into your home folder in a .wily directory, or you can configure it to go in another directory. So, for example, you could put it in a shared folder, or you could put it somewhere else, which is a separate Git project. The challenge with having it in the same Git repository is that basically it's checking out each revision and it's changing the folder at the same time. So basically Git is not going to be happy because you're going to have, unstaged changes within your working copy. So it won't let you actually go and check out different copies without losing the files. So basically the Wiley cache has to be in a separate, either a separate Git project or a separate directory. It can't be in the same one at the moment, unless you just ignore it completely. So if you add the folder to .git ignore, then it will work fine. But like I said, by default, it'll put it in your local directory.
And do you have any potential thoughts of maybe adding some pluggability to the data storage mechanism for those metrics so that perhaps you could have it interact with a shared remote database backend so that you can update the complexity metrics in a sort of shared environment that everybody can view in sort of a dashboard?
Yeah, I mean there are services that do this already. Code Climate would be one. So I know Code Climate uses some of the similar metrics, and it has a GUI. So I think it's free for open source projects. Really, kind of where I wanted to work on Wiley was for projects which are not open source, or for whatever reason they're proprietary, because that does make up the bulk of Python projects are not all on GitHub. I mean, I know there are some big projects on there, but lots of people work for corporates, and they can't really share this information publicly, especially when it comes to sensitive stuff like bugs and complexity, which could potentially get into the hands of some of their competitors. So it was really kind of designed as an offline tool originally. But yeah, I can definitely think about ways that it could be extended. I guess the one way I'm thinking about next is the complexity is one thing, but really another thing I'm interested in is how the complexity also impacts the performance. And when I've been looking at tools for profiling Python applications, there's a few really good command line tools that can create the data, and there's a web service that the Python performance website uses, which is quite cool. You can give it a whole bunch of benchmarks to run, but really there's not a tool that can basically go and give you a good breakdown of what is consuming all the CPU usage in your particular app, but do that historically. So something I'm thinking about next is how Wiley could potentially do that.
And another thing that I was just thinking about is that because of the fact that Wiley is able to do static analysis of the code and doesn't actually require execution of it, it simplifies some of the potential issues that could arise of traversing the historical record of the repository in terms of needing to maintain the dependencies as they shift over time, whether by adding or removing them or changing the version numbers. So because you're just purely looking at the code as it sits on disk and maybe parsing the abstract syntax tree without actually having to necessarily pull in all of the dependencies, I imagine that simplifies the overall effort required.
Yeah, definitely. So that would make it extremely complicated. So all the benchmarking tools today rely on having the profile hooks in the CPython runtime or whichever runtime you're using, and they basically look at the time to execute certain statements and functions across the AST. So what I was thinking about is how you could do that statically. So without actually running the code, how could you come up with some sort of performance profile? So something I was thinking about is associating a cost basically with each node type in the AST. So an if would have one certain cost. A list comprehension, for example, would have another type of cost, but within that, then you'd associate costs with comparing strings, for example, looking at floating point numbers. Calling functions has a cost, as we know, as in Python. So basically giving you a metric that looks at some of the known costs in terms of the CPU cycles potentially for each of the operations without actually running the code. Obviously, it's not going to be hugely accurate, but it's better than nothing.
Yeah.
And if you look at historically a project, going and running that project 100 times is fine, probably on a little project if it's just a CLI. But if it's a big project that needs databases and APIs and everything set up, I think it'd just be impossible to go and historically do that.
Yeah, absolutely. And I think that what you were pointing out of having these statically defined sort of cost metrics that are in some ways just abstract and arbitrary, but important relative to each other would still give you some useful signals as to areas that might be worth exploring, but definitely worth additional validation, but just a way of being able to focus the effort rather than having to take everything as a potential cost saving measure.
Yeah.
And other than the complexity and some of the potential benchmarking or profiling tools, what are some of the other useful metrics that you've found for being able to track and maintain the overall health of a software project?
Yeah, I mean, if it's a collaborative project, then something else that's useful is looking at the number of contributors, the number of maintainers. Is there a single person who seems to do, who has to solve all of the hard problems? So, is there basically like not a single point of failure, but is there a lot of knowledge wrapped up in one individual person on your project? So there's a whole bunch of tools that do that for open source projects, some online ones, which I'll share with you, which also look at the number of maintainers you've got, how many external people come in and contribute. Which is really helpful. Another, I guess, is looking at the metrics in terms of the number of bugs reported against different components in the code base. So this is something that I know a lot of large projects do. Internally, in terms of their bug reporting tools, they try and drill down and associate those with components or modules in the code. So you could basically look back and say, here's a heat map against where we get bugs reported across our code base. Now, I'll always remember there's a graph that showed the number of bugs reported against the MySQL project. And if you looked at it historically, it basically had a direct correlation with the number of users. So those metrics you need to be really cautious of, because basically it's to do with footfall. So if you've got a lot of people using the project, then it's a lot more likely that they're going to find issues. So having a large number of users typically means that they're going to explore every possible different scenario that can happen, every different state that could happen with your application. So having a low number of bugs doesn't always mean that your code is really stable. Sometimes it just means that very few people are using it.
And once you've identified some potential problem areas in your code base, whether from finding locations that have a high amount of complexity or issues with potential performance or IO operations, what are some of the possible approaches for being able to improve the overall health of the code base and reduce the complexity and improve performance, and some of the ways to ensure that you're doing it safely?
Yeah, so it depends on the metric you're looking at. So if something has a really high cyclomatic complexity, it typically means that there is a lot of nesting in that piece of code. So you would look at flattening the function, and there's a whole bunch of techniques you can use to do that. You can return early, for example. You can use different styles in Python, or if you're working with nested dictionaries, for example, that tends to introduce a lot of nesting in the code, because you're checking whether these attributes exist and you're looking at indexes and you're flicking through things. But there's actually a lot of other tools you can use to work with nested data sets. So I've talked about a few of those. Glom is one. that's pretty cool. Another one is called ASQ, sorry. Ask ASQ is another tool. They're basically sort of like querying tools for dictionaries. So you can put everything in a single statement and it'll give you back some of the results. So yeah, those are other ways you can basically reduce nesting and complexity by querying data a lot better in the code base. And then if you've got another metric which says that the volume of code is too high, this particular module is just enormous. It's 7,000 lines of code. You've got 25 classes defined in it. So basically, you just lumped everything in this mega module in your project, which makes it really difficult for people to work on. So that's, I guess, where the refactoring tools come in. So you can't really just break up a module and just shift stuff all over the place just by copying and pasting. I think you're going to introduce a lot of bugs in terms of the way you can do imports in Python, and you don't tend to compile up front in Python either. So you're only going to discover that there's some module expecting to import a class from something you've moved when it's too late. So that's where some of the refactoring tools come into play.
And in terms of the refactoring tools that you have dealt with, which of them have you found to be most useful and most user-friendly?
The most powerful one I've worked with is built into PyCharm. So when you load a software project into PyCharm, it basically, understands everything within the project, what modules there are, the names, classes, functions. So it's not just a dumb code editor that you're just changing the files on the file system. Basically, almost interprets the entire project and also loads up the virtual environments for you and understands the libraries and the dependencies. And that's really important when you do refactoring, because if you do something as simple as renaming a function, then knowing everything that calls that function is really hard, because, for example, you could just do a quick search in the project to just look for that function name and see everyone who's called it. But for example, people could do renames on imports, and there's a whole bunch of other times where people could call that function as an object reference or use it as a wrapper, for example. So it's actually quite tricky to find references to things with just a dumb code editor. So PyCharm, has some really advanced tools for refactoring that are great. So if you want to change signatures, move things around, rename stuff, it'll actually go and look through the whole project and figure out all of the changes that would need to be made, and it will stage those for you and show them, and then you can approve each one in a sequence.
And another thing to keep in mind when you're doing that too is if there are any external users of the code that you're modifying. So if you're working on a library project or working on a service that exposes an API that other projects might be consuming, then you need to be cognizant of the fact that you might be potentially breaking the contract that they're expecting when they're interacting with your software. So making sure that you have a deprecation process or a means of advertising the fact that the API or the function name or the function signature are changing so that anyone else can make the necessary modifications in their code as well.
Yeah, definitely. It's tricky to manage with Python because nothing is really private in Python either. So people could have used your code in all sorts of weird and wonderful ways. But I guess if you've got a documented API contract on the library, then it should be easier to change in a smooth way.
And what are some of the aspects of developer-oriented tooling that you have found to be most important as you're building various projects, such as Wiley or any other tooling that you have had a hand in building and maintaining?
Yeah, I guess some of the complexity tools are useful. I also care a lot about the layouts and the documentation. So PyDoc style is by the Python QA team. So this is where other projects like PyLint live, for example. So both PyDoc style and PyLint I find really useful. PyLint I find useful because it will warn you about typical bad practices. For example, if you create a class with only one method other than the init method, then it probably should just be a function. So PyLint will go and warn you against all those sorts of things. Or if you've got a function that has like 50 parameters, 50 arguments in it, then it will warn you against stuff like that as well. So I find PyLint really useful in giving you warnings. PyDoc style being really useful in terms of looking at the doc strings and your functions and methods and making sure that they're laid out properly and they follow a good style. And then on top of that, I've been using Black recently as a code formatter, which I found really useful. And again, using it as a pre-commit hook. So I mentioned the pre-commit project earlier and using Wily as a pre-commit, but basically using Black in the same way. So I don't even need to think about running it. It just does it when I do a commit. And then if there are any changes, then it'll tell me that it's been updated, and then I run the commit again and they're all staged.
And in terms of the way that you approach the design of your own developer tooling, what are some of the best practices that you have found in terms of making sure that it is easy to use and intuitive and makes sense for developers rather than increasing the burden of their work?
I guess probably one of the biggest things is consistency in terms of how you name things, the names of the parameters, the sequences in which they go. So if you're building a command line application, for example, making sure things are in the same order across different commands, the output looks similar. I just see so many tools where even in other languages, for example, I don't know if you've ever worked with PHP, and I think you have in the past, but whether or not it's needle or haystack or needle depends on the function. When you're doing string searches, some functions have underscores, some of them don't. It can just get really confusing and it's inconsistent. I know that's changed in newer versions, but I think consistency is probably the main thing when you're designing a developer-oriented tool, because people need to memorize these things. They can't look it up in the documentation every time.
But yeah, I can definitely agree to having consistency in terms of the overall implementation and being consistent with the broader sort of community standards and idioms so that it's not introducing a lot of cognitive overhead of, for instance, looking at Python functions where they're using camel case so that you're confused as to whether you're in your JavaScript code or your Python code, or working in Java, which uses maybe Pascal casing. So maintaining community standards and expectations so that there is less effort necessary for people to be able to get comfortable and familiar with your tools.
Definitely.
And so what do you have planned for the future of Wiley, or any other tools that you might have in mind to help your team and help yourself in the projects that you're working on for building and producing healthy and maintainable software?
Yeah, so I think it's really going back to the performance point. It's if Wiley can give you some kind of CPU cost or operation cost of a project just by looking at the AST, so being able to do that statically is something that I'd be really, really interested in doing. And then the other thing is looking at the reporting functionality. So at the moment, it gives you a basic line chart and you control the axis and stuff like that. But in future, I'd like the ability to have a more interactive style, so be able to drill into particular modules. And to see it in something called a sunburst, often called a sunburst chart, which is basically it's almost like a series of pie charts stacked on top of each other. But it's a really good way of visualizing a software project, because you'd see in the innermost ring, the 3 or 4 modules you have in there, and then on the outer rings, as you go through the project, you can see all the different levels. So yeah, I recommend looking at those. But that's really what I'd like to do, is improve the reporting functionality and come up with some better metrics around performance.
And are there any other aspects of your work on Wiley or code complexity or overall software maintainability that you'd like to discuss further before we close out the show?
Yeah, the other thing I've been looking at is Visual Studio Code, which has got a couple of refactoring tools in it, but just discussing with the developers of that at the moment, potentially improving those, adding some more features and functions, which I think would be really cool. So that's the other thing I'm kind of looking at the moment.
And for anybody who wants to follow along with you and keep up to date with the work you're doing and get in touch, I'll have you add your preferred contact information to the show notes. And so with that, I'll move us on to the picks. And your mention of the Sunburst Chart reminded me of a tool that I've used called Baobab, which is it's a Linux tool for being able to scan and find the various relative sizes of directories on disk, so you can figure out which folders are taking up the most space on your hard drive for being able to clean things out and keep your hard disk available. And then the other pick that I have is a TV show that I started watching recently with my wife called Impractical Jokers, which is just about it's a group of friends who put each other up to various sort of embarrassing or awkward situations, and it's a competition to see who can follow through on the various scenarios. And it's pretty funny. It's painfully awkward at times, but it's been pretty entertaining, so it's worth a good laugh. And so with that, I'll pass it to you, Anthony. Do you have any picks this week?
Yeah, I've got a couple. So on the TV side, I've been watching Line of Duty recently, which is a UK kind of crime drama, but it looks at corruption in the police force. But it's really kind of gripping thrilling episode. So I'd definitely recommend that. And then the other one is a podcast. So if anyone out there has kids, if anyone out there has girls, then there's a podcast called Fierce Girls, and each one is a story about a famous woman actually they're all Australian, but they're basically stories of our first female prime minister, one of the first female surfboarders, for example. So they're really good stories for the younger ones, and they talk about all these amazing women over history.
All right. Well, thank you very much for those picks and for taking the time today to discuss the work you've been doing on Wiley and building developer tooling and maintaining healthy projects. So I appreciate that, and I hope you enjoy the rest of your day.
Thanks. Great to see you again.